Imagine standing on the Giza Plateau around 2500 BC. Before you is not just a structure of stone. It is an artificial mountain, a colossal geometric form blazing beneath the Egyptian sun, once covered in smooth white Tura limestone, so bright it could reflect light for miles. At its very top, a shining capstone of precious metal catches the first light of dawn. This is the Great Pyramid of Khufu. Even today, in an age of giant cranes, 3D models, and advanced engineering software, the pyramids of Egypt still force us to ask one of history's greatest questions. How did the ancient Egyptians build them? No steel, no engines, no heavy machinery, no trucks, no cranes, no modern concrete. And yet they created a structure nearly 147 meters tall, using around 2.3 million stone blocks, with a level of precision that still amazes engineers today. So how did they do it? The answer does not lie in aliens. It does not lie in magic. And it does not lie in the old image of thousands of chained slaves being whipped into submission. The real answer is far more impressive. It lies in the combination of religious belief, state power, mass labor organization, practical mathematics, astronomy, and above all, a logistical system so sophisticated that it still surprises us more than 4,000 years later. To understand how the Egyptians built the pyramids, we have to go back to the beginning. Not to the first stone that was laid, but to a time when the pyramid itself had not yet been invented. The pyramid was not a perfect invention that appeared overnight. It was the result of generations of experimentation, failure, correction, and improvement. Before pyramids, Egyptian kings were buried in structures called mastabas, rectangular tombs with flat roofs and sloping sides, usually built from mud brick. Then, during the reign of King Djoser, a major breakthrough took place. His architect, Imhotep, did something unprecedented. Instead of building one mastaba, he stacked several on top of each other, creating the Step Pyramid at Saqqara, the first large-scale stone monument in history. It was the moment humanity moved from building tombs to building artificial mountains. But the Egyptians did not stop there. Under King Sneferu, father of Khufu, they began trying to create a true smooth-sided pyramid. They experimented at Meidum, where the structure likely suffered a major collapse. They tried again with the bent pyramid, but had to change the angle halfway through because of structural concerns. Finally, they succeeded with the red pyramid, the first true smooth-sided pyramid. In other words, when Khufu ordered the construction of the Great Pyramid, the Egyptians were not starting from zero. They already had decades of experience with stone construction, foundation leveling, weight distribution, and architectural failure. The Great Pyramid was not a miracle. It was the peak of a long learning process. Before a single stone could be cut, the Egyptians had to answer a basic question. Where should the pyramid be built? The ideal site needed to meet several conditions at once. It had to lie on the west bank of the Nile, the side associated with the land of the dead, where the sun sets. It had to be close enough to the river for materials to be transported by boat. It needed a strong bedrock foundation capable of supporting enormous weight. And it had to be elevated, visible, and symbolically powerful. The Giza Plateau met all of those requirements. Once the site was chosen, the next step was leveling the ground, a task that may have been even more important than stacking the stones themselves. If the foundation was uneven by even a small amount, that error would be magnified as the structure rose higher. Researchers believe the Egyptians may have used water-filled trenches to establish a perfectly level base. Water always finds the same level. By cutting channels, filling them with water, and marking the height, they could create a nearly flat foundation. It was a simple idea, but simple ideas applied carefully can build wonders. After leveling the site, the builders had to align the pyramid with the 4 cardinal directions. What is astonishing is that the Great Pyramid is oriented almost perfectly to north, south, east, and west, with only a tiny margin of error. No magnetic compass, no GPS, no laser surveying equipment. The Egyptians likely used the stars, especially the circumpolar stars, the so-called imperishable stars that never seemed to set, to determine true north. That means from the very beginning, the pyramid was not merely a construction project. It was a work of engineering, astronomy, and religion at the same time. One of the biggest myths about the pyramids is that they were built by slaves. Modern archaeology strongly suggests this is false. The people who built the pyramids were mostly organized laborers employed by the state, including skilled craftsmen, stonecutters, haulers, sailors, supervisors, bakers, brewers, cooks, doctors, and seasonal workers from farming communities. During the Nile flood season, many farmers could not work their fields. At that time, the state could mobilize them for large public projects like royal tomb construction. This was a system of corvée labor, a form of taxation paid through work rather than money. Excavations of workers' villages near Giza show that these laborers were relatively well fed. They had bread, beer, fish, and meat, enough to sustain heavy physical effort. Some skeletons even show evidence of healed fractures and medical treatment. That does not mean the work was easy. It was brutal. But these were not masses of nameless slaves suffering in chaos. They were part of a highly organized workforce. Some crews even left graffiti with proud names such as the Friends of Khufu and the Drunkards of Menkaure. That sounds human. It sounds real, and it sounds very different from the old legend. To build the Great Pyramid, the Egyptians needed different kinds of stone. The most of the pyramid's core was made from local limestone, quarried directly on the Giza Plateau or nearby. This was the most practical material for the immense bulk of the structure. But the outer casing, the surface that once made the pyramid gleam white in the sun, was made from fine Tura limestone, quarried on the opposite side of the Nile and transported by boat. For the internal chambers and key structural spaces, especially the king's chamber, the Egyptians used granite from Aswan, hundreds of kilometers to the south. Some of these granite blocks weighed dozens of tons. So, how were they cut? For limestone, workers could use copper chisels, stone hammers, wooden wedges, and levers to carve channels, loosen blocks, and shape surfaces. For much harder granite, they used pounding stones made of dolerite, an extremely hard rock, to hammer away at the stone over long periods of time. Imagine the sound of that construction site. Stone hammers beating against granite, chisels striking limestone, workers shouting in rhythm, wood scraping across sand, boats knocking against the riverbanks. The pyramid was not born in silence. It was born in the noise of an entire civilization at work. Cutting the stone was only half the challenge. The other half was moving millions of blocks to the right place at the right time. And here, the Nile was everything. The Egyptians did not merely live beside the Nile. They built their civilization around its seasonal rhythms. During the flood season, rising water levels allowed boats to travel farther inland through canals and side branches. This turned the Nile into a natural transport highway. One of the most important discoveries related to pyramid construction was found in 2013 at Wadi al-Jarf, the Diary of Merer. This is one of the oldest known papyrus documents ever discovered. In it, an official named Merer describes how his crew transported Tura limestone by boat through canals to Khufu's construction site. This document does not explain every detail of how the pyramids were built, but it confirms something extremely important. The Egyptians had a well-organized river transport system for moving stone. Once the blocks reached the construction area, they were likely dragged across land on wooden sledges. And here we find one of the most elegant details in all of ancient engineering. In an ancient image, a person stands in front of a sledge and pours liquid onto the sand. Many researchers believe this liquid was water. Modern experiments have shown that wetting the sand in front of a sledge can significantly reduce friction, making it much easier to drag heavy loads. No magic, no super technology, just physics, observation, and experience. This is the biggest question of all. And it is also the one for which there is still no single universally accepted answer. We know the Egyptians could quarry stone. We know they could transport stone. But how did they raise millions of blocks higher and higher as the pyramid grew? The most widely accepted answer is ramps. But what kind of ramps? Straight ramp. This is the simplest model to imagine. A large straight ramp would rise from the ground and the blocks would be dragged up along it. Its advantage is simplicity. It may have worked well during the lower stages of construction when the pyramid was still relatively short. But if one enormous straight ramp had been used all the way to the top, it would have needed to be incredibly long and would have required a vast amount of material, possibly more than the pyramid itself. So, if straight ramps were used, they were probably used only in the early stages. External spiral ramp. Another theory suggests a ramp that wrapped around the outside of the pyramid. This would reduce the total length and material needed, but it introduces a serious problem. It would block the corners and outer faces, making accurate alignment much more difficult. And precision is exactly what the Great Pyramid has in abundance. Internal ramp. Engineer Jean-Pierre Houdin proposed that the Egyptians may have used an internal ramp system hidden inside the body of the pyramid. According to this idea, blocks were dragged upward through a spiral passage within the structure itself, with occasional openings at the corners to allow turning. It is an intriguing theory because it solves several problems at once, but it has not been definitively proven. Levers and stage-by-stage construction. Another possibility is that the Egyptians did not rely on one single method. They may have used low ramps, wooden levers, temporary platforms, and different lifting systems at different heights.
In other words, the pyramid may have been built through a flexible, changing construction strategy rather than one universal technique. What matters most is this. Whatever exact method they used, the Egyptians were almost certainly working with simple mechanical principles: dragging, sliding, levering, lifting, balancing, and reducing friction, but applying them at a scale never seen before.
Building a giant pile of stone is difficult. Building one with extraordinary accuracy is something else entirely. The four sides of the Great Pyramid are aligned almost perfectly to the cardinal directions. Its base is remarkably level. Its corners are nearly exact right angles, and the slope of each face is highly consistent. The Egyptians achieved this through practical surveying, not modern formulas. They had measuring cords, wooden stakes, cubit rods, and a crucial concept known as seked. Seked was the Egyptian way of expressing slope. For every cubit of vertical rise, how many palms did the pyramid extend horizontally? It was a highly practical system. It allowed builders to reproduce the same angle over and over again without using modern trigonometry. This shows that the Egyptians did not need our equations to understand geometry. They understood it through measurement, ratio, and repeated practice. They did not need to call it advanced mathematics. They only needed to build it correctly. Many people imagine a pyramid as little more than a giant solid mass with a few simple tunnels inside. But the interior of the Great Pyramid reveals a much higher level of design. Inside are passageways going upward and downward, the soaring Grand Gallery, the so-called Queen's Chamber, the King's Chamber, and narrow shafts leading outward. Most impressive of all is the King's Chamber, built from heavy granite blocks with a series of relieving chambers above it. Why were those chambers necessary? Because if millions of tons of stone pressed directly onto a flat ceiling, the chamber might collapse. The Egyptians solved this by stacking granite beams and creating spaces above the chamber that redirected pressure away from the room itself. That is structural engineering. Real structural engineering. It shows that the Egyptians were not simply piling up stone. They understood that weight had to be managed. Even in the 21st century, muon scanning technology revealed a large hidden void above the Grand Gallery, a mysterious empty space that remains unexplained. That discovery reminds us of something important. Even after more than 4,500 years, the Great Pyramid has not given up all its secrets. Building a pyramid was not just an engineering problem. It was a problem of state administration. To keep the work moving, the Egyptians needed a constant supply chain: stone from quarries, wood for sledges and boats, copper for tools, rope, food for thousands of laborers, water, beer, livestock, medical care, and supervisors to coordinate every step. This was a national project. The pyramids were not built by muscle alone. They were built by systems. During the flood season, seasonal workers could be brought in from across the countryside. Crews were divided into teams, shifts, and specialties. Strong hauling teams moved blocks. Skilled masons shaped and placed stones with precision. Supervisors tracked progress. Boat crews handled river transport. The entire worksite functioned like a living machine. And at the center of that machine stood the pharaoh. Not only because he gave the order,
but because in Egyptian belief, building for the king was part of maintaining cosmic order itself.
When we look at the pyramids today, we see rough yellowish stone, stepped surfaces, and weathered edges, but that is not how they originally looked. When completed, the pyramid was covered in polished Tura limestone casing stones, fitted so tightly and smoothly that the outer surface may have looked almost continuous. Under the desert sun, it would have shone brilliantly. At the top was likely a pyramidion, a final capstone, perhaps coated in gold or electrum, catching the first and last light of day. That means the final stage of pyramid building was not just about getting the stones into place. It was also about finishing, smoothing, polishing, and transforming the structure into a visual symbol of divine power. It was a tomb, a monument, a political statement, and a material image of sunlight itself. If we had to summarize the secret of pyramid construction in a single sentence, it would be this. The Egyptians did not build the pyramids with one lost invention. They built them through the perfect combination of many intelligent solutions. They chose the right site. They leveled the foundation with extraordinary care. They aligned the structure using the stars. They quarried stone from multiple sources. They used the Nile as their main transport route. They dragged blocks on sledges across wetted sand. They used ramps, levers, and temporary platforms to raise the stones higher. They measured carefully using ropes, rods, and the Seked system. They organized thousands of workers into disciplined labor teams, and they sustained the entire process over many years. The pyramids are not mysterious because they were impossible. They are mysterious because we often underestimate the ancient world. We assume that without modern machines, ancient people must have been helpless before a task like this. But Giza proves the opposite. With enough time, enough organization, enough belief, and enough practical knowledge, human beings can accomplish what seems impossible. When we ask, how did the Egyptians build the pyramids? We often expect a simple answer, a single secret, a lost technology, one magical solution. But the truth is more complex than that. The pyramids were the result of generations of accumulated knowledge, of failures turned into lessons, of a state capable of mobilizing and feeding a massive workforce, of builders who understood material, weight, slope, and geometry through deep practical experience, and of a civilization that believed building for the pharaoh was not merely architecture, but a sacred duty tied to the order of the universe. That is why the pyramids still leave us in awe, not because they are beyond human understanding, but because they are one of the greatest proofs of what human beings are capable of. No steel, no engines, no futuristic machines, just willpower, organization, knowledge, and time. And perhaps that is the most astonishing part of all, that more than 4,500 years ago, on the edge of the Nile, human beings built something so vast and so enduring that time itself could not silence it. The pyramids do not just show us what the ancient Egyptians built, they show us what humanity can do.